All right, in this video, we're gonna look at changing this matrix into reduced row echelon form. In other words, we wanna take A and turn it into matrix I. Because we don't have an augmented matrix here, just a 3 by 3, so we're gonna turn it into a 3 by 3 identity matrix. And for each operation, we wanna define the corresponding elementary matrix, and then look at the end how we could put those all together. So let's start. First of all, I think I'm going to do leave row 1 alone, and I'm going to do row 2 minus 2 row 1. Okay, so if I do that, my corresponding elementary matrix, I'm going to call that E1. So I'm leaving row 1 alone. I'm going to do row 2 minus 2 row 1. So negative 2, 1, 0. Leave row 3 alone. All right, if I do that, I'm going to end up with 1, 3, 5, 0, negative 5, negative 9, 1, 5, 3. Okay, so I could verify this, but we showed that above in the previous example. So I'm going to let this matrix now be A1. So matrix A1 is E1 multiplied by matrix A. All right, so I'm going to take my A1, 1, 3, 5, 0, negative 5, negative 9, 1, 5, 3. So now I'm going to get rid of this one down here. So I'm going to leave I'm going to think about my elementary matrix over here. So elementary matrix 2 is going to be leave row 1 alone, leave row 2 alone, and row 3, I want to do, let's do row 3 minus row 1, so negative 1, 0, 1. Okay, so when I do that operation, this is going to yield 1, 3, 5, 0, negative 5, negative 9, and then 0, 2, negative 2. Okay, so this is looking really nice. I'm going to half this. 1, 3, 5, 0, negative 5, negative 9, 0, 1, negative 1. Oops. All right, so in doing that, the elementary matrix that would correspond to this would be 1, 0, 0, 0, 1, 0, and then I would have 0, 0, 1 half. Okay, so coming back to this matrix I could say is A2, and A2 is the same as E2 multiplied by A1. That, of course, would be the same as E2 multiplied by E1 multiplied by A. So I'm just continuing to pre-multiply by all of these elementary matrices. So let me slide this one down a bit. This one is now going to be my A3. And all right, so now I'm going to let's get rid of this one, because I'm trying to turn it into my identity matrix. So I would end up with 1, 3, 5, 0, negative 5, negative 9. If I multiply this by 5, 0, 0. So I'm multiplying by 5 and adding it together, negative 14. All right. So to get that, 1, 0, 0, 0, 1, 0. And now I multiplied row 3 by 5 and added it to row 2, 0, 1, 5. Okay, so there's A4. And remember, A4, I could write as well as E1 times, let's just write it down. A4 is E4 times E3 times E2 times E1 times A. All right. Divide by negative 14 is going to give me a positive 1 down here, which is what I want. All right, sorry, E5. One zero 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 1 0 0 0 1 14th. Right. Now I can multiply by 9, add these two together. All right, so E6, 1 0 0. Now I multiplied row 3 by 9 and then added. So 0, 1, 9. One, 3, 5. Oh my goodness. Zero, 1, 0, 0, 0, 1. So in this case, multiplied by negative 1/5 on row 2. And my last one, A8, I'm going to end up with my identity. And the way I'm going to end up with this identity is I am going to take row 1, subtract 3 of row 2, subtract 5 of row 3. Leave the other two the same. So here's my A8. So let's sum this up. So A8 was E8 times E7 times E6, E5, E4, E3, E2, E1 times A. Well, A8 is the same as the identity. That means that this product here must be equal to the inverse. So the result of ending up with the inverse, if we take all these elementary matrices and multiply them together, what we're going to end up with is the inverse. So we have found the inverse without needing a formula for the inverse. Of course, we have to perform all of these multiplications, but if we keep track of them as we go along, it's not too bad. And then we have our inverse matrix. So we're going to talk about that some more in the upcoming video.